Hello everyone, welcome to Women Who Code Connect India 2022. This session is launch your own crypto token. Crypto has been a trending word for a while now, and blockchain is a technology that enables the existence of the cryptocurrency, among other things. So, to talk more on this, today we have with us Sweta Shah, a postgraduate from IIT Bombay, is a full stack blockchain developer with experience in working with 10 plus EVM protocols. She expertises in writing secure smart contracts and ship cool apps. As a member of Developer DAO, she has contributed significantly to the ecosystem. She has also provided workshop to 100 plus executive professionals and mentors students for Solidity cohorts. In her free time, you will find her reading books or playing a sport. With that, a very warm welcome to you, Shweta, and the stage is all yours.
Thank you so much, Amulya. So today we will be seeing how we can launch our own crypto token. I know crypto buzzword is so much popular among so many people. So today we'll see hands-on how we can launch our own crypto token. Cool. With that, let's see. First, understand a few things about how Web 3.2, how the blockchain architecture actually works. So this is how Web 3.0 architecture looks like. Like in the Web 3.2 architecture, what we have is when a user browses something or requests something from the web server, the request from the front end goes to the back end. Unlike in Web 2.0, wherein the request used to go to some database in the back end, for example, MongoDB, Apache, any such kind of database, and it used to fetch response from there and display it in the front end. But here what happens is the request goes to the blockchain. Here I have taken example of Ethereum blockchain, which is basically runs on EVM, that is Ethereum virtual machine. So from the front end, request goes to the back end, that is Ethereum virtual machine. And how does this link happen between the front end and the virtual machine is through smart contracts. So how should they know which logic to learn or what kind of results to give to the front end? It depends on the smart contracts, the code within the smart contracts, right? This is how the entire thing is built like. Next, we will see the we will see how to develop these smart contracts, as in we will be writing smart contract to launch our own crypto token. So first we need to also understand what are crypto tokens, what are the different protocols that exist in blockchain. These are basically called ERC standards. Whenever we want to launch our own crypto token, we need to follow certain standards, right? Because today I am launching my own crypto token, someone else is launching their own crypto token. So there needs to be some synchronization between all these tokens so that all the processes happen in a synchronous manner. So what does this ERC stands for? This ERC stands for Ethereum request for comments. So what are these ERC standards? These are basically standards that needs to be followed whenever someone is launching their own crypto token. There are many kind of ERC standards. These standards are for many things, maybe how contracts interact with each other, how you write your own smart contracts. So today we will be basically focusing on ERC20 standards. That is what we will be launching today. So this graph shows the evolution of the token standards with year. As we see, ERC20 was first launched in 2015. It was in 2015 that ERC20 was first launched. This request was first put up. In 2018, a new standard called ERC71 was launched, and in 2019, ERC1155. I know these might sound jargons to many people, but let's understand what these tokens are. Basically, ERC20 is basically fungible tokens. Fungible in the sense this can be exchanged with one another. For example, USDC, DAI, or any such ERC20 tokens that are in place. What does fungibility mean? Fungibility means that even if I have one DAI and you have another DAI, the value of both the dice will be same. This is very much similar to what fiat currencies are. If I have a 100 rupee note and you have a 100 rupee note, the value of both the 100 rupee note will be same, irrespective of if I have a newer note and you have an older note. Okay, like, but the value of both the notes, both the currencies will be the same. But what are ERC 721? ERC 721 are basically called non-fungible tokens, or you might have heard the phrase or the word NFTs. NFTs, that is non-fungible tokens. For example, what are the examples of NFTs? These are Bored Ape Yacht Club NFTs or CryptoKitties NFTs that you might have known. That these are sold like for millions of dollars. Yeah, these are very high in value. So what is so unique about ERC 721? The most unique thing about ERC 721 is that it's non-fungibility. Non-fungibility means if I have one for example, say Bored Ape token, Bored Ape NFT, and someone else has Bored Ape NFT as well, but it need not be that the value of both the NFTs are the same. Okay. Next is ERC 1155 token standard. This is basically best of both the worlds, best of both ERC 20 and ERC 721. In ERC 20, what is there is it is mainly fungible tokens. ERC 721 is for non-fungible tokens. But using ERC 1155, we can launch both fungible and non-fungible tokens. Some examples of ERC 1155 tokens are redeemable shopping vouchers. When you want to launch a similar kind of token in bulk, in those cases we use ERC 1155 token. Since this will be a very hands-on session, I totally recommend everyone to just dive in and let's do code along and launch our own ERC 20 token live. So for this, okay, and here these are basically the standards that we can see. Uh, so basically, I'll show you the standards of what are there. So as you can see, these are basically EIP 20 standards. So it contains all the rules and regulations about launching your own ERC 20 token. So what they say is whenever someone tries to launch their own ERC 20 token, they need to implement these functions, and functions like name, symbol, decimals, total supply. So what does this function name mean? It basically, this name is the name of the token that you want to launch. Okay. Symbol is the symbol of the token. Cool. So yeah, so these you will find all the functions, all the events that needs to be implemented over here. Okay. Now if we want to launch our own ERC 20 token, we need to implement all these functions that are present over here. But the whole process has been simplified by OpenZeppelin. OpenZeppelin has released their own library of ERC 20 token, which we can use so that we need not again and again implement these functions. Okay. So we will see and use that library to create our own ERC 20 token. So these smart contracts that we'll be writing right now, we'll be using Solidity language for that, and we will be using online IDE for it. You need not install any IDE on your laptop. It will just require this online IDE called Remix, and we will start coding on that. So I'll share my screen and show you what Remix IDE looks like. So as you can see, this is the Remix IDE that you can use. You can go to this URL called remix.ethereum.org. So this is where you need to go. So once you go to this Remix IDE, what you can see here on the left hand side, this is your workspace where you can create all the files and folders that you want to work on. And I'll gradually explain everything whenever time comes during this whole process. First, what we need to do is we can click on this file icon over here to create a new file, and you can name it something called my crypto token. SOL stands for solidity. That is the extension for any solidity file. Okay. Next, the first line that goes into any smart contract, Solidity smart contract, is the license identifier. First is this which we write it in comment. So this basically identifies if the code that you will be writing, what license does it hold, basically. Next, what we need to write is the Solidity compiler that we will be using. So we will be using Solidity compiler, for example, say 0.24. Okay, we can just... So if you see any error here, you can just go and select the compiler that you want to use from here. Or you can just put this. Next, we will be writing the contract, that is my crypto token. For this, so basically in Solidity, what happens in smart contracts, what happens if you're coming from other programming languages, we have something called class over there. So in smart contracts, we have class replaced with contract. Just does that only. Class being replaced as contract, nothing else. Okay. Next, what we will do is we will import the ERC20 libraries from OpenZipline. Okay, next we will import the libraries from OpenZipline, that is this. And we will be using this ownable library because we want this contract to be ownable. Ownable as in whosoever is deploying this contract, he or she will be the owner of this contract. Yeah. So that only the functions over here can only be called by the owner who is deploying this contract. Not everyone can come and call the functions in your contract. Okay. Next, what we will do is we will call the constructor. Like other programming languages, we have constructor in smart contract as well, in Solidity as well. So we are just calling that constructor. Along with the constructor of our contract, that is my crypto token, we will also call the constructor from ERC20 token. So we are calling the constructor from ERC20 library, that file. And what does this accept? This constructor accepts first variable as first parameter as the name of the token. So I can write women code token, and I'll write the symbol as WWC. This is the name of the token and the symbol. Okay, and inside this constructor, yeah, we need not do anything over here. Uh, I hope everyone is with me. If you have any doubts or anything, you can just put it in the chat. Okay. Now, before we use this ERC20 constructor, we need to uh, inherit it. Yeah. So we need to inherit this library from ERC20 contract over here. Also, since we want to use this enable contract, we will be importing enable as well. Next, we will write a function called mint. So what this function will do is this will mint the ERC20 tokens to the address that we define. So this is to parameter. It takes the address to whom we want to mint that token, and we want the amount of tokens that we want to mint to that address. Okay, and what it will do is it will call mint function. Function mint, yeah. Mhm. Okay, so you might be thinking where this mint function has been defined. This mint function is getting called from the ERC20.so, the ERC20 file. So if we go to this file, so as you can see, this is the ERC20 contract that we are using. This contract has been released from OpenZipLink. If you see over here, this function, this contract takes in constructor with name and symbol as its parameter. So whatever parameter we passed over here, like women who code token and WWC, this is being passed over here, this constructor. Okay, and this gets stored as the name and symbol of the token. And whenever we inherit any contract, all the functions that are present in that contract, all the public and external functions that are present over there, these get available for use in the contract we are inheriting it. Okay, and if you see, there's a mint function over here. See, you can see the mint function over here, underscore mint, which takes in the address. That is what it takes. What it does is creates amount tokens and assigns them to account. So basically it takes first parameter as the account to whom we want to mint those tokens, and the second parameter is the amount. That is the amount of token that we want to mint to that account. Okay, so we are calling this function over here. Okay, there are a few things about this function. We want to make this function public. Also, we want to make it only owner. Okay, so that only the owner of the contract can use this, so that only the owner of this contract can call this mint function. Okay, cool. I hope everyone has done till here. Awesome. I hope everyone has finished till here. Next, what we will do is we will compile this Solidity our smart contracts. So for compiling, what you can do is you can press Control S or Command S over here. Pressing Command S or Control S will compile this program. You can also compile it from here. If you go to the fourth icon over here, that is compilation. This is the compilation tab. If you click here, you will get this button over here to compile your Solidity contract. Okay, you can just press over here called compile. It will, the arrow button will go on and it will say that it is compiling. Next, it will show a green tick if it has compiled successfully. You can see it has compiled successfully. Next, what will go and deploy this contract. Okay, so what we can do is just don't get bothered about other things present over here in about the environment. Account is basically the dummy account. So what Remix does is it gives you some dummy accounts with some dummy ethers to work on. So here you can see so many accounts. So basically, I guess they give you 10 or 20, 12 accounts, 10 or 20, something like that. So these many accounts they give you with dummy ethers so that you can experiment with your code. Okay, now next, just let's dive in and let's go and deploy it. If you click on deploy, you see here that the contract has been deployed. Okay, so you see the contract has been deployed and you can see the transaction hash and everything from to. So here you can now access the functions that are there in your smart contract. If you click on this arrow button over here, you on the left hand side you see a section called deployed contracts. You'll see an arrow button over here. Just go over there and you will see there are so many functions that are available for you from the smart contract. First, let's check the name of our token, right? Let's see. Yeah, so for name we have women who code token, and let's see name symbol of the token, that is WWC. Awesome. Next, decimals, we have 18 decimals by default. If you want to change the number of decimals that your token should have, you can change it. Now let's see if I have any tokens as such. So let's click. This is the account, owner account, and let's see if I have any token over here. Balance of. So this balance of function, what it does is takes in the address of the account that we want to check the balance of, and I'll just paste my address over here and I'll see if I have. So I have zero token over here. Next, let's mint some token. So I'll call this mint function. Let's call this mint function. What it will do is it first takes the address to whom we want to mint the token. So let's click on my address, click on the address over here, and then what you can do is paste over here and the amount that you want to mint. So basically we will, yeah, let's transact. Awesome. So the token amount has been minted. Let's check my balance now. Yes, see my balance. I have these many tokens. See, it got changed, right? So isn't this like awesome? Now let's do one thing. Instead of doing it all in using dummy accounts, let's use MetaMask. So I don't know if you have MetaMask installed, but if you don't have MetaMask, what you can do is you can just go to, you can add MetaMask extension in your Chrome or Brave or whatever browser you're using. So basically, let me share my screen again. So you can just go to your Chrome Web Store or Mozilla extensions anywhere and just add. So since it is already added to my Chrome, it is asking me to remove it over here. But you will, if it's not already added, you can just go and you will get something like add to Chrome, some option like that. Yeah, just go and add your MetaMask, add MetaMask to your browser. Okay, so once your MetaMask account is ready, what you can do is, just give me a moment. You can just go over here in the drop down, in the environment drop down, and click on injected provider MetaMask. Okay, what it will do is it will try to connect your MetaMask account. Click on next and connect. Okay, what it will do is it will populate the account address that you have on MetaMask. It will do is it will so whenever we click on injected provider MetaMask, it will populate the account address with the address that you have over here. Okay, so this is my account address over here. So it will populate with the same address here, and it will fetch the same balance. See, I have 0.6 rinky by 8. It will populate with the same 0.6 rinky by 8. Okay, so what this will do is this will enable you to use your MetaMask account to interact with the smart contract and deploy the smart contract on whichever network you want. So we will be using Rinkiby. So you can get some dummy Rinkiby 8 test. It's from this chain link. So if you go over there, I'm sharing the so if you go to this website called pockets.chain.link, what you can do is you can select which network you want to get. I'll connect my MetaMask. I'll connect it over there, and it fetched my account address and the network. And from here, what we can do is we can get the test it. Okay, just verify that you are a human being. Click on this, blah blah, and then you can just whenever you verify that you're a human being, it will pop up this button will get activated, that is send request, and you can send request and get some 0.1 test it to your account. Now what you can do is we can use that 0.1 test it to launch our own.
Shweta, do you want to share your screen?
Sorry.
Do you want to share your screen?
Oh, I am not sharing. Oh, okay,
No.
sorry. Okay, sorry. Yeah, now I'm able to now my screen is visible, right?
Yes, please continue.
Yeah, so now what you can do is you can go to okay, sorry, I guess you might have missed Chainlink website then. Yeah, so what you can do is you can go to you can go to this website. You can go to this website, and here you would have gotten just I'll show you again. Yeah, so you must, when you go to this website, you will see something like this. You can go and connect your wallet, use MetaMask wallet, and then it will some MetaMask pop-up will come up where you can do just next and connect. Once you connect, you will see your account address get populated over here, and zero point 0.1 test ETH that they will be providing you once you verify yourself as a human. Okay, so once you verify this, the entire thing just this send request button gets activated, and you can just use this send request button, click on the send request button, and get 0.18 into your MetaMask account. Now once you get the ETH test ETH into your account, what you can do is we will just come back to our we'll come back to our Remix IDE, where we can just launch our own crypto token. So now my MetaMask is connected over here, you can see, and the account. Now we'll just go and deploy. Now when we'll click on deploy, it will pop up the MetaMask. I think you might not be able to see it because I'm only sharing the tab over here. But you will be able to see. Wait a minute. Let me see if I can do something over here. Okay, no. So let me do one thing. So yeah, so whenever you click on deploy, uh, MetaMask pop-up will come up, which will ask for the transaction to take place, and you need to click on confirm. Once you confirm, you can see over here creation of my crypto token pending, and now with a green tick, it says that it has been deployed. What we'll do is we'll go to Etherscan, view on Etherscan, and we can see the transaction over here. As you can see, this transaction happened just 25 seconds back with from my account to contract. So this was the new ERC20 token contract that was created. And now if you want to import yeah. Now you can import the token. So you can go over here, copy the contract address, you can go over here, copy the contract address that was just deployed. So this is a contract that was deployed. Click on the copy icon and just copy it, and then move to MetaMask. Now if you move to MetaMask, once we move to MetaMask, what we can do is here you can see assets, something called import tokens. Click on import tokens, paste the token contract address that you created, and you will see that it got automatically populated with the token symbol, that is WWC, the token that we created just now. And then you can do add custom token, and then import tokens. So right now I have 0 WWC tokens. So what we can do is I'll go and copy my address over here and move to Remix, where we had the So now what we'll do is we will go and mint some tokens to my address that we just created. I mean, from the MetaMask. So this is the wallet address that I copied from MetaMask, and I'll mint some tokens to this address. So how much should I mint? Something like this. Wow, nice. We just do the transaction. But this transaction won't go. The reason I'll say, yeah, so this transaction happened. Okay. So this transaction happened, and let's see. I'll transact some more. I will transact some more tokens. And we can check the balance. So this is my account address that I copied from MetaMask, and this is the balance function. So right now I have this much amount of WWC tokens. Now let's verify this on Rinkibi Etherscan, how much token I have. So we can just go to MetaMask. We can now go to MetaMask, and now you see I have so many WWC tokens. You see, so it shows that there were two mint functions that were called. So two times this minting happened on this on my account for this token. I can even go to Rinkibi Etherscan and check what's my balance. So if you go to Rinkibi, paste your address over here, and this is what happened. So 5 minutes back, the contract creation transaction happened where the contract was created for a ERC20 token. Next, I minted some tokens. This transaction is for that. See, it minted 0.0001 women who code tokens. And then again, I minted again some more token for this much amount. You see, these many women who code tokens I minted. Isn't it beautiful? So basically, this is how you can launch your own crypto token or currency and use it for your own needs, or you can just create a whole application around your own token. As in, you can create an app that uses only that requires only your token to perform the operations on your application, and that way you can create a whole value around your token, right? So I'll also show you something more, that is, this is a token tracker. Okay, so what you can see over here is the women who code token tracker. What it shows everything about this token, that is WWC token. Okay, it has this much maximum supply. There are only one holders, that is me. Only I am holding these tokens. There were two transfers that happened. So this is the two transfers that happened, and it has about 18 decimals, and this is the contract address of the token. Okay, and this is how the entire ERC20 token is done. I am open to questions. If anyone has any questions or any doubts, you can just ask me uh, in the chat, or yeah. And if you want to know more about NFTs, I can show you how we can, the way we did for ERC20 tokens. Similarly, what you can do is you can use the OpenZeppelin library called ERC721 and use that to create your own NFTs as well. I can show you that. Just give me a moment. So this is it. So this I'll show you. Yeah. So what you can see here is the same, the way we did for ERC20 token, that is for fungible tokens. This is one for the NFTs, that is non-fungible tokens. So here what we're using is ERC721 library from OpenZipLink. And yeah, the same kind of thing. Here we are writing the name of the NFT, that is called the Phoenixes, and the symbol of the NFT is the TPG. And here what we can do is we can create token over here. And so this function, what it does is, this is called create token. It accepts a token URI. Token URI is basically the details of the NFTs. So everything that you want your token should have. For example, if we go to OpenSea, so if you go to OpenSea and check, I'll show you. So for ERC721, what you do is so you need to first signify or define all the kind of values. For example, one of the major examples of NFTs are the gaming tokens, gaming NFTs. So in gaming NFTs, there are many kind of features that every character has. For example, the skin of the gaming character, the eye, the hair, the kind of weapon or something like that, that a character has that resembles a character. So everything, all the details of it, you need to define in a JSON file, and you need to host that JSON file in some place, maybe IPFS. So and then use that IPFS link to create your own NFTs. So for example, as you can see over here, so this is OpenSea, where you can see all the tokens like NFTs that have been created. Okay, so this is an NFT with something called token standard ERC721. It was launched on Rinkibi. Okay, so this all these images and everything, this come from, so this come from the token URI basically. So this is, you can see over here the properties, it says level is premium. So whosoever, so these kind of values, that what kind of properties it should hold, these come from the token URI. So for creating token URI, there is whole lot of standards that needs to be followed. OpenSea has released their own standards for ERC721. So if you go to this link, OpenSea, you have all the metadata structure that ERC721 token should have. For example, the description of the token, the image, name, attributes, and in attributes, you can show something like personality, mouth, eyes, base. So everything that you want, you can describe over here, like in this format, the trait type, the value, the everything. So trait type is base, eyes, how the mouth should be, level, okay, stamina. So everything over here you can see, you can define for your character or the NFT that you want to create. And yeah, that is it. I'll just show you a type of token URI file that you can create. So you can create something like this. Okay, so let me show you over here. So just you can see over here that this is how the JSON format should be: the description, the URL, image, name, and everything. So once you have this kind of JSON file, what you can do is you can just pin it on IPFS or Pinata, something like that, and then use it to create your own token. So with that, we are towards the end of this session. I hope you enjoyed, or like you created your first ERC20 crypto token today, and I hope you liked it.
Perfect. Thanks a lot, Shweta. That was very interesting. Even the remix idea looked very simple, and people can go start exploring even if they've not started with that. So, once again, from the Women Who Code team, thank you, Shweta, for your time today.
Thank you so much.
Bye, everyone.